Good afternoon, everyone. My name is Sanjana Golaya, and I am a data science and business analytics intern at the Graduate Rotational Internship Program at the Sparks Foundation. And this is my video for the first task that was given to us. The objective of this task was to predict the percentage of a student based on the number of study hours. So it was a simple linear regression problem for which the data set was provided to us as a CSV file, and we had to use a supervised machine learning algorithm to get to the output. The code for this project is also given in my GitHub repository, the link for which I've included over here, and I've also included a QR code which you can scan, which will take you to my repository page. Now I'll quickly take you to the Jupyter notebook where I've performed the code and go through it. Here we are at the Jupyter notebook. So firstly, going through all of the imports that we'll be needing in this code. Firstly, we've imported pandas and numpy as basic data reading and data manipulation libraries, and then we've included matplotlib and seaborn, which are data visualization libraries, so we'll be using them for graph plotting. I've also included a line over here which is matplotlib inline. So what it basically does is when you plot a graph or any other kind of plot, you can basically see the plot within the Jupyter notebook itself, and you don't have to use the dot show method every single time. So starting off with the code, we've read the CSV file that was given to us in the task list using the pd.read CSV function. I'll quickly take you to the data set over here, the CSV file that was given to us. So as you can see, there are just two features in this data set. We have hours and we have scores. So it's a pretty simple data set. There are just two features, and there are about 25 entries in this data set. So as can be expected, we'll receive good accuracy at the end of this project, because this data set is pretty simple. Now going back to the code, we'll just quickly check the head of the data frame, which we've named as df over here. df.head will give us the first 5 values of the data frame. So as we saw and from the data set, and as can be expected, we just have two features, hours and scores. Next, we can also check out some basic information about the data frame. As you can see, there are 25 entries and there are a total of 2 columns, and the type of the data in these 2 columns is also given over here. So we have float for hours and we have int for scores. Next, what we do is we basically divide this data frame into 2 parts, wherein one is the part which has the features that we'll be giving into the model, and what we'll get from the model is basically y over here. So we've divided the data into x and y. X is basically the hours column which we will be inputting in the final stages, and y is something that the model will return to us as the scores that it predicts. Next, I've basically just checked out what x and y are. As you can see, they are numpy arrays. They are one-dimensional arrays over here, as you can see, and the type of x is float and the type of y over here is int, as was mentioned in df.info. Next, we've done some basic visualization using sns.join-plot. We've used the kind scatter, so we can basically see a scatter plot over here between hours and scores, as hours is on the x-axis and scores is on the y-axis. So as you can see, it's a pretty linear graph right at the beginning. As the number of hours increase, the number of scores increase as well. Moving on, we come to the machine learning part of our code. For this, we basically import train test split from sklearn.model selection. What it basically does is it divides our data into training data and testing data. And what we ideally want is the training data to be around 70 to 80% of the total data set, and the testing data to be accordingly 20 to 30% of the total data set. So this statement x train, x test, y train, y test equal to train test split, which is a method, and we pass in x and y, and the train size that we've used over here is 0.7. So basically 70% of the entire data frame will be used for training purposes and 30% we'll be using for testing. Here I have reshaped x because basically what train test split will be expecting is a 2D array instead of a 1D array. However, since we just had one feature, what we've had to do is we've had to reshape it into a 2D array. Moving on, from sklearn.linear model, we will import linear regression, and we will create a linear regression model using this statement. And here in the case, we'll actually have to call linear regression as opposed to this statement. Moving on, we fit the model according to the values that we have used train test split to get, which is x train and y train. So we fit our model according to x train and y train. And then after we fit the model, we can check out a variety of parameters like coefficient, intercept, and other things as well. Here I have shown the value of the coefficient and intercept. So in basic mathematical terms, or we've studied y equal to ax plus b as the equation of a line. So in this case, a over here can be the coefficient and b over here can be the intercept. So going by that formula, y equal to ax plus b, the regression line that we'll be getting for this model will be lm dot coefficient into the value of x plus lm dot intercept. This I have given the variable name as regression line. Next, what we do is we have a plot that basically compares the regression line along with the scatter values of what was given in the data set. So basically we have a scatter plot for the values of x and y, which basically shows us what were the actual values that were given to us in the CSV file. And then we have a basic line plot, which is basically giving us the line that we have obtained over here using y equals to ax plus b. So using this, we get a pretty good idea as to what our model is predicting and what are the actual values, and more or less the actual values are lying pretty close to the regression line. So we can say it's a good fit. We've used basic functions like x label, y label, and title to get some more clarity into the graph as to what the x-axis is, what the y-axis is, and so on. Next, we move on to the predictions part of this code. We'll use lm.predict to predict all of the values for the array, which is x test. So 30% of the data set or 30% of x was basically used to train to test the model, as opposed to 70% which was used to train the model. So now for all the values of x test, we will predict values of the score for the input values of ours. So we've stored this in an array known as predicted values. Now what I've done next is I've plotted a data frame in which I have given one column as the predicted values and one column as the actual values. So as you can understand, predicted over here is what our model has given by this statement, predicted values equal to lm dot predict. And we've given the input as x test, and the actual values is what was given to us in the CSV file. So as you can compare, the difference isn't much. So we had the actual value of 69 in the first case, and we got a predicted value of 74. And in the second case, we had an actual value of 88 and we had a predicted value of 92, and so on. I've just shown a data frame over here comparing these two values. Now, as in any linear regression model, we have three basic evaluation metrics, which are mean absolute error, mean squared error, and root mean squared error. So we can evaluate any sort of linear regression model using these three metrics. For this, we'll basically import metrics from sklearn, and we can use the following statements to get the values of mean absolute error, mean squared error, and root mean squared error. Metrics dot mean absolute error, and then we given the values of y test and the predicted values, and it compares and gives us the mean absolute error, which in this case we got to be around 5.32. Mean squared error in this case we got to be 29.578, and the root mean squared error obviously was root, which is basically 5.4386. Now the last part of our task was to predict how much a student will score if he studies 9.25 hours a day. So in this case, what we do is we give hours of student as a 2D array, because that's what predict will expect, as 9.25, and then the score of the student can be found out using lm.predict, and then we pass in the hours of the student, which in this case is 9.25, and we get the output as 92.699%. So in conclusion, if a student studies 9.25 hours a day, we can expect him to get 92.699% in his exams. So that's about it for this task. Thank you very much.